Hello dear students, I welcome you all to online class on set theory class 11 mathematics. So far we have learned Venn diagram, various kind of sets, right? And today we will see or we will learn practical problems on sets. So far we have not seen any problems based on set theory, but today we will start with the practical problems that we may apply in our daily life. Okay, so the formula to be used here are mentioned out here. So you may pause the video and note down all the formula. Okay, so let me take first question for the day, and I am taking question number 2 from exercise 1.4. So question says, if x and y are two sets such that x has 21 elements, y has 32 elements, and x intersection y has 11 elements, how many elements does x union y have? Okay, so basically since they are talking about number of elements present in a set, so basically they are talking about cardinality. Okay, so cardinality's formula starts from 3 to 8. Okay, so you have to use any one which is suitable for the problem. Alright, so question says cardinality of x, that means number of elements present in x is given to be 21. So whatever is given I am just noting them down. So given is n of x, cardinality of x is given to be 21, right? Cardinality of y is given to be 32, alright, and the number of elements present in x intersection y means cardinality of n intersection y, x intersection y is given to be 11. Now as per the question, we need to find how many elements are there in x union y. Alright, so we have to find this, and if you compare this, we have to make use of this formula, because this is my a union b, that's x union y, which we need to find. N of x is given, n of y is given, and n of x intersection y is also given to us, right? So let's make use of formula 3. So we know that n of x union y can be written as n of x plus n of y minus n of x intersection y. Alright, so let's put the value. So n of x is given to be 21 plus n of y is given to be 32 minus n of this is given to be 11, right? So let's find out how much is this. So 2 plus 1 is 3, so this is 5 minus 11, so this turns out to be how much? This is 2, this much, right? So your number of elements present in x union y will be 42. Pause the video and note it down. Let me take question number 4 for you. So question says, if n of a union b is given to be 18, n of a minus b is given to be 5, n of b minus a is given to be 3, you need to find n of a intersection b. So what is given? Let's see. So given is, okay, so as per the question, these many things are already given to you and you need to find what is the value of this, isn't it? Now let's make use of the formula which are available with us. So we have got the formula for this, isn't it? So formula 5 says this will be equals to, see, instead of this I am using 5 and writing n of a minus n of a intersection b, and this will be equals to, see, instead of this I have written this, and this is equals to how much? 5, isn't it? Now let me write down the same for this. I am using formula number 5, and this becomes your n of b minus n of b intersection a, isn't it? But a intersection b and b intersection a both means the same, so that's why I am writing here this much. Alright, so this turns out to be how much? 3. Okay, so let me call this as equation 1 and let me call this as equation 2. Okay, now adding 1 and 2, let's see what do we get. So adding 1 and 2, we see that we have n of a plus n of b minus n of a intersection b, right, minus n of a intersection b. If you add, right? Okay, so we have 5 plus 3 out here. Now if you see here carefully, how much is this? So this will be equals to n of A union B using 3, isn't it? So instead of this I am writing n of A union B minus we have n of A intersection B, and this is equals to 8, right? So let's put the value of n of A union B. How much is this? This is equals to 15. So 15 minus n of A intersection B is equals to 8. Take this over there. So you have 15, this 8 comes here, minus 8 equals to n of A union, A intersection B. So basically what is the value of cardinality of A intersection B from here? So this turns out to be 18 minus 5, which is how much? Which is exactly 7. So my answer for this particular question will be this one. Pause the video and note it down. Now let me take question number 5 for you. Now 5 is similar to 4, but still we'll do once more so that you will find it easy to do the other sums. Alright, so we have question number 5, which says if A and B are two sets such that, so whatever things are given, let me write. So this is question number 5. So given so there are 3 questions which are asked. So first is you need to find what is n of A union B. So it's the other way around now. Okay, so you need to find n of A union B. Next you have to find is n of A, and next you have to find is n of B. So there are 3 parts. So let's start. So again, as usual, I am writing these two as n of A minus n of A intersection B. Alright, using 5. So this will be equals to this much, isn't it? So let me call this as 1. We have this can be written as n of B minus n of A intersection B will be equals to 3. Let me call this as equation 2. Now I am doing the same again. Alright, so or what you can do is you can use this here and find the value of n of A. Okay, so let me call this as 3. So using 1 and 3, so let me use this and this. So we get n of A minus this. Instead of this I am using 10 equals to 5. So from here what is n of A? N of A turns out to be 15, isn't it? So this is my one of the answer. Okay, now let me use 2 and 3. Okay, so using 2 and 3, so again we have n of B minus n of A intersection B, which is how much? 10. So this is equals to how much? 3. So from here we see that n of B turns out to be 13. So this is my another answer. Now what is left over? We need to find n of A union B, and for that we will make use of formula 3. Okay, so since n of A union B is equals to n of A plus n of B minus n of A intersection B. So let's put the values now. So what is n of A? N of A is 15, n of B is 13, minus n of A intersection B is given to be 10. So when you add them you will get 28 minus 10, and when you take the difference, what will be the difference? Your difference will be 18. So that's why this will be your third answer. So pause the video and note it down. Alright, so let's take question number 7. So question 7 says, okay, so whatever is given, I am just noting them down. So given is, okay, so these are the things which are given to us. That means n of xi means the number of elements present in universal set is 48, and this is given to us. Now if you see here, we can apply De Morgan's law. Okay, so here we have A dash union B dash. So here also we have got A dash union B dash. So instead of this, can we write this? Yes. So we have, this can be written as n of A intersection B dash. Alright, so instead of this I have written this much. So this is 36. Now if you see here, n of A dash, okay, can be written as n of xi minus n of A. Now what is A here? This full thing acts like A. N of A dash, yes. So instead of this I am writing n of xi minus n of A. What is A for me? This full thing is A, isn't it? So we have this much equals to 36. Alright, so let's put the values. So n of xi is given to be 48 minus n of A intersection B is equals to 36. Take this out there. Alright, so you'll get 48 minus 36 will be equals to n of A intersection B. That is, when you subtract this, what will be the difference? It will be 12, isn't it? So therefore, n of A intersection B will be equals to how much? It will be equals to 12. So pause the video and note it down. Okay, let's have a look at question number 9. So in question number 9, these are the things which are given and we need to find what is the value of this. Okay, so I'm applying again this formula, formula number 8 out here. So if I apply formula 8, this full thing is my A. Alright, so this can be written as n of xi minus n of A, and this full thing is my A, isn't it? So we have A union B equals to 6. Alright, now what is n of xi? N of xi is 50, isn't it? So let me write n of xi to be 50 minus n of A union B equals to 6. You take this over there and get this out here. So you will find that n of A union B will turn out to be 44. Alright, so don't skip the step. I have directly shown you out here. So n of A union B turns out to be this much. But we need the value of this, isn't it? Now, in order to find the cardinality of A intersection B, we have to make use again this. Alright, and we have the value of this, we have the value of this. And in order to find the value of this, we should know what is the value of this as well. And we already found the value of this here just now. Alright, so therefore, if I apply that formula, we have n of A union B equals to n of A plus n of B minus n of A intersection B. Now let's put the values. So we have n of A union B is equal to 44 equals to n of A. N of A is 20 plus n of B. N of B is 26 minus n of A intersection B. Simplify this and get this thing out here, take this over there, you'll find that n of A intersection B will be equals to exactly 2. So this is my first answer. Alright, now next thing is we need to find what is n of A minus B, and we know that n of A minus B using this. Okay, so I don't have space, let me erase this here. We have n of A minus B can be written as n of A minus n of A intersection B. So what is n of A? N of A is 20, and what is n of A intersection B? Just now we found it to be 2. So my answer will be 18 for the cardinality of A minus B. Pause the video and note it down. Okay, let me take question number 10. So question 10 says, if n of xi is 50, n of A is 30, n of B is 28, then find number 1 the greatest value of n of A union B. Okay, so you need to find greatest or maximum value of n of A union B. So this is my first question, and the next question says find the least value of n of A intersection B. That is, least means minimum value of n of A intersection B. Alright, now let's try to understand here very carefully. Alright, because this question is a bit tricky out here. So first and foremost, let us see what will be the maximum value of n of A union B. Alright, so we know that n of A union B is equals to n of A plus n of B minus n of A intersection B. Right? Okay, now if you see here carefully, to make this maximum, we want to find the maximum value, right? So to make this maximum, this quantity has to be minimum, because you are subtracting this quantity, and the minimum value possible here will be 0. Okay, so if you make it 0, then you are getting the addition of two numbers, which makes this naturally the biggest number possible, right? So for example, if I put this to be 0, okay, so if I make this to be 0, I am not saying this is equal to 0. If I make this to be 0, then we have n of a is how much? N of a will be 30 plus n of b will be 28. So total will be how much? 58. Alright. Now A union B contains 58 elements, but what is happening? Your universal set contains 50 elements. That means A union B is forming a bigger set than universal set, isn't it? So that's why there is a problem out here. So that's why the maximum value for A union B will be only 50, not 58. Are you understanding? It can be 58, okay, but since the universal set contains only 50, so all the 50 can be your number of elements in A union B. Alright? Okay, so as I said, for maximum this has to be list, and if this is made to be 0, then we get that n of A union B contains 58 elements, which is not possible as universal set contains 50 elements. Okay, that means if the maximum value of this, okay, so if the universal set contains 50 elements, that means the maximum value that this can attain is only 50. Now if this is my maximum, I said this has to be minimum. This has to be minimum in order to make this maximum, right? Now what am I going to do is, let me take this out here. So you will have n of A intersection B, and here you will have minus of n of A union B. Now in order to make this minimum, what you need to do is you have to make this maximum, isn't it? Now what is the maximum value of this? This is 50, right? And this is 30 plus 20 is 58. 58 minus 50 is how much? It is 8. So that's why the minimum value of n of A intersection B will be automatically 8. Alright. So this is how we do this kind of sum. Pause the video and note it down. Now having understood these sums, now let's try to apply the very same kind of technique in word problems. So let me take the first word problem, that is question number 11, which says in a group of 400 people, so there's a group of 400 people, and out of that group, or in that group, 250 can speak Hindi and 200 can speak English. Okay, so there's a group of people, and in that group of people there are two languages being used. One is Hindi and one is English. Okay, and among them, among those 400, 250 speak Hindi, can speak Hindi, and 200 can speak English. Alright, so what is the total out there? So total becomes your 250 plus 200 is 450, but there are how many people? There are 400 people. Now what's the meaning of that? That means that there are some people who speak both Hindi and English. Alright, now according to question, how many can speak both Hindi and English out? Now let's see how to apply these formula in such kind of problems. Alright, so for applying these formula, we need to define some sets here, right? Set means collection or group of people. So let me write this question number 11. So let A be the set of people speaking Hindi. Alright, and let me write B as the set of people speaking English. Alright, so therefore if you see here carefully, we have n of A, that means number of people belonging to this set, that means number of people speaking Hindi. It is given to be how much? It is given to be 250, isn't it? And we have n of B equals to number of people speaking English, which is given to be 200, right? Now what is given to us? Total number of people. So if I include both Hindi and English people, then total becomes 400, isn't it? So basically n of, or if I combine the people speaking Hindi and English, okay, so combining means union. So if I combine, then the number is how much? Number becomes 400. All right. So therefore, according to question, we need to find what is the number of people speaking both Hindi and English. So please remember, whenever you see or, you have to write union, okay, and whenever you have and, then you have to make use of intersection. You need to remember these two things. All right. So Hindi and English means we have to use intersection. Okay, so therefore n of A intersection B has to be found, and we can find n of A union B, A intersection B using formula number 3 again. Okay, so if I take this over there and get this over here, then this can be written as n of A plus n of B minus n of A union B. Now let's put the values. So we have n of A is 250, n of B is 200, and n of A union B is 400. So simplify this turns out to be 50. So there are 50 people who speak both the language. So therefore, English. All right, so pause the video and note it down. Now let's take question number 12. So in a class of 60 students, 25 play cricket, 20 students play tennis, and 10 students play both the games. Okay, so here they are talking about classroom. Okay, so in that classroom, so classroom is, you can consider this as your classroom, and there are how many students? There are 60 students. So this classroom becomes my universal set. All right, so remember that. Okay, now we have 25 students. Okay, so let's write down what are the things given. So given is number of students in the class. So this is given to be 60, and as I said, this classroom is my universal set, so that's why this can be written as cardinality of universal set, which is 60. All right, now it is given that from this classroom 25 play cricket. Okay, so let A be the set of students playing cricket, or who plays cricket. All right, so if this is so, okay, so let me take another set as well. So B is the set of students playing tennis. So therefore, what is given to us? N of A, number of people or number of students playing cricket, is given to be 25. Yes, and what is number of people who is playing tennis? It is given to be exactly 20. Okay, so now as per the question, we need to find the number. Okay, so one more thing is given, that 10 students play both the games. That means cricket and tennis. So and means intersection is given. So n of A intersection B is given to be 10. Now as per the question, we need to find the number of students who play neither, who doesn't play cricket also and tennis also. Okay, so therefore number of students who play neither will be equals to, okay, so n of what? Let's see. So it will be n of A is the set of students who plays cricket. That means A dash will be the set of students who doesn't play, right? Complement means it's just the opposite, you have to put not. So set of students not playing cricket will be A dash. Okay, so A dash contains the people who do not play. Now we need to consider the people who do not play tennis as well. So we need to have here and, isn't it? So doesn't play cricket and doesn't play tennis. So doesn't play tennis means it should be B dash. All right, now let's apply De Morgan's law out here. So you see that this is present in number 1. So instead of this, I am writing this much. Okay, so we have n of, so this can be written as A union B complement, and we know that if I apply this formula, formula 8 here, then we can write this as n of xi minus n of A union B. right? So basically what do we need to do is we need to find what is n of xi is already given, right? So let's find what is n of A union B using this formula. Now let's apply this formula directly out here. So this can be written as n of xi minus, since minus is there, so all the sign will reverse. So we have n of A minus n of B plus n of A intersection B. Alright, so let's put the value. N of xi is given to be 60 minus n of A. N of A is given to be 25. N of B is given to be 20 plus n of A intersection B is given to be 10. So let's simplify this. So after simplifying, this becomes 70. See here, 60 plus 10 is 70 minus 45. Yes, so 70 minus 45 is how much? It turns out to be 25. Alright, so pause the video and note it down. Now let's take the problems based on this particular formula. So basically, till now whatever problems we have seen, there we have made use of only two sets. So in this formula you will see that there are three sets present. One is A, B and C. Okay, so let's try to apply this formula in our word problem. So let me take the first question based on this is your question number 17. Okay, so let me read the question. In a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T and 26 read newspaper I. So basically there are three kinds of newspaper H, T and I. Alright, so let me form the set first. So let A be the set of people reading newspaper H, okay, B okay, so these are the three categories I have made out of 60 people, isn't it? Yeah, so it is given that 25 people read newspaper H. That means therefore n of A is given to be number of people reading newspaper H will be equals to how much? 25. N of B is given. N of B is given to be, that is number of people reading newspaper T is given to be 26. Number of people reading newspaper I, that is N of C is given to be again 26, I guess. Yes, 9 people read both H and I. H and I means A and C. Alright, so number of people reading H and I, that is N of A intersection C is given to be 9. Okay, another thing that is given to us is 11 read H and T. H and T means A and B. So N of A intersection B is given to be 11. Alright. Next is 8 read T and I. So T and I, that means B intersection C. N of B intersection C is given to be how much? It is given to be 8. Alright. And at last it is said that 3 read all 3 newspapers. That means H, T and I. So all are being read. So this means N of A intersection B intersection C, because reading all the newspaper contains and H and T and I. So and means intersection, and this number is given to be exactly 3. Now whenever you deal with problems on 3 sets, it's always better that you draw Venn diagram and work, okay, so that your work becomes simple. How? Let's see here. So this is your universal set. Alright, so in this universal set you have got 3 sets, right? So this is one set, this is another set, and this is your third set. Let me call this as A, B and C. Okay, now as per the question, we need to find the number of people who read at least one of these or one of the 3 newspaper. So at least means minimum, remember, at most means maximum. So you have to find the number of people who read at least one newspaper. So at least means he might be using newspaper H, that means he might be in set A. He might be reading T, that means he might be in set B, or he might be reading I, that means he might be in set C. But it's not possible, see, it's not necessary that he reads only one newspaper. He says at least one should be read by that person. That means he can take any number of newspaper. That means he can read 2 newspaper, 3 newspaper as well. That means he can read, if he is reading newspaper H, then he can read T as well, alright, because there is no bound for maximum number. Only thing that is said is minimum he has to read one newspaper. Maximum he can read all the newspaper. So that means he can take A, he can be either in A or B or C. So or means what? Or means union. So basically, as per the question, he is asking number of people reading at least one newspaper will be given by, see here carefully, either he will be in A or B or C, isn't it? So either or means we have to write, or we want to find this in our case, alright. And if I use this formula, I am not writing the formula, you will write by yourself, alright. So we have n of A. So what is n of A? N of A is 25. Next we have plus n of B. N of B is given to be 26. Next we have n of C, that is 26. We have n of A union B. A union B, I'm sorry, this is A intersection, alright, not union, it is intersection. So A intersection B is given to be 11 minus n of B intersection C, which is given to be 8 minus n of C intersection A, or A intersection C, both are same. So this is given to be 9 plus, at last we have this one, which is given to be 3. Alright, so let's calculate how much is this. So let's add all the plus together. So this is 77, 80, right? So 80 minus, so this becomes here 28. So this is equals to how much? So if you find the difference, so 10 minus this 2, so 7 minus this is 52. So our answer for the first one is 52. Alright, now the next part says, find the number of people who read exactly one newspaper. Now in order to understand this, let's try to use this Venn diagram. So exactly one newspaper means either he might be using only A, so only A means this one, isn't it? So only A is this part. These are the people who reads only newspaper A, right? Or you can take newspaper B, and the people who read newspaper B is only these people. Are you understanding? Okay, so these are the people who read only newspaper B, and we have got another category, that is newspaper C as well, and these are the people who will read only newspaper C. I'm sorry, the newspapers are given to be different, H, T and I am saying A, B and C, but try to understand, alright. So these are the people who are reading newspaper C, okay. So if this is the case, or yeah, if this is the case, then we need to find what are the number of people reading exactly one newspaper. Okay, so this is number 2. So number of people reading exactly one newspaper. Okay, so how to get my answer? Let's pay attention out here. Now initially I am taking the group of all, or let me combine all the sets. So if I combine all the sets, then I'll get this full thing, isn't it? So everything will come. So everything means what? This is n of A union B union C. So I have taken the people who read all the newspaper. All the means at least one newspaper, or I am taking everything. Alright. Now from this everything, what am I going to do is, I am going to remove this part. See here carefully. I am going to remove this part. Okay. Now what, because from this group I need to take out this part, no? Isn't it? So if I take out this part, what is this? This is A intersection B, isn't it? So I am removing A intersection B. Alright. So this much part is already gone. Okay. So let me erase this. So this much part is already gone. So we have now, we have to remove this part. Yes, and this part. Now I don't know what is this set. Do I know? I don't know what is this set. So what am I going to do is, I'll remove this set here. Okay, but you must be saying, sir, we have already removed this part. Yes, we have removed this part, but we don't know how to remove this, no? So that's why I'm removing this part, and I'll again add this part to nullify. Are you understanding? And what is this? This is common to all the three sets, isn't it? Which is what? Which is this one. Are you understanding? This part is common to all. That is, this is A intersection B intersection C. Okay, so let me first remove this full thing. Now what is this full thing? This full thing is what? This full thing is A intersection C. So N of A intersection C is removed. Now again, let me erase this. Now again, see, I have removed this part, I have removed this part, now I have to remove this part. So again, I cannot remove only this much, so let me remove this full thing. And how much is this full thing? This full thing is N of B intersection C. Alright, okay. Now what I have done here is, as I said, I have included this twice. Once for this and once for this. So I have to subtract this twice. Alright, remember that. Okay, so we need to include this. Okay, so since we have subtracted, no, we are subtracting here. So in order to nullify this, what we have to do? We have to add these two. Okay, so these two are removed, no? So we have to include these two. And what are these two? There are 2 times. See, I have removed this twice here and here. So that's why I have to add them up twice. So that's why 2 times N of A intersection B intersection C. Alright, so this is how we find the number of people reading exactly one newspaper, and in other cases also you will see the same cases coming again and again. So it's better to use always Venn diagram. Okay, so let's apply, or let's put the value out here. So N of A union B union C is given to be how much? It is given to be 52 minus N of A intersection B is given to be 11 minus A intersection C is given to be 9 minus B intersection C is given to be 8 plus 2 times this, right? So this is given to how much? 3. So let's simplify this and see how much do we get. So 2 into 3 is 6. So 6 plus 52 is 58 minus this is 28. So your answer for this particular question turns out to be 30. Alright, pause the video and note it down. Okay, so let's take question number 19 for you. So in a survey of 25 people, so this is question number 19. So in a survey of 25 people or 25 students, it was found that 15 had taken mathematics. Okay, so let me write A as set of people taking maths, or set of students. It will be better if you write students out here. So set of students who have taken maths. Next is we have got, okay, so we have N of A, that is set of students who has taken mathematics is 15. Number of people are 15. 12 has taken physics. So taking physics means N of B is given to be how much? It is given to be 12, and 11 has taken chemistry. Alright, so N of C Number of people taking chemistry is given to be 11. 5 had taken mathematics and chemistry. So there are 5 people who has taken mathematics and chemistry, means A intersection C is given to be 5. Alright. Next is number of people. Okay, 9 had taken maths and physics. So maths and physics means A and B, and the number is 9. Next is 4 has taken physics and chemistry. So physics and chemistry means B intersection C is given to be 4, right? And at last, who has taken all the 3 subjects is 3. That is N of A intersection B intersection C is given to be 3. Now here there are many questions, sub questions. So there are 8 sub questions. Alright. So what am I going to do is, here I'll find out whatever is C. First and foremost, we have got only this formula available for 3 sets. So let me find this. Alright. So therefore N of A union B union C, you will first write down the formula and put the value. So we have N of A, that is 15, plus N of B plus N of C minus N of A intersection B 5 minus 9 minus 4 plus 3. So if you apply the formula and put the value, then your answer will be, so we have, let's add together the plus. So 3 plus 1 4 plus 6 11. Yes, so 11 1 carried over 1, so this is 41 minus, so if you add them up, so we have 14 minus 18. So let's subtract. So this turns out to be 11 minus 8 is 3, so 3 minus this is 23. Alright, so this is my N of A union B union C. Now let's see what are the different questions being asked. So before that, let me draw Venn diagram for you. Okay, so here we need to find number. The first question says find the number of students who had taken chemistry only. Okay, so chemistry means we are dealing with C. So basically they are asking chemistry only means this much. Okay, so we have to find the number of students belonging to this shaded portion. So what am I going to do here is, see here carefully, we will take C. Okay, so from this C we will remove this part and this part. Alright, so this will be given by, number of people belonging to set C minus, now what is this? This is A intersection C, isn't it? A intersection C, so N of A intersection C. Now this much is removed means now we have to remove this part again, but we don't know what is this. So what am I going to do is, we will remove this entire part. Okay, and we will add this part again to nullify. Alright, so we have minus, this full thing is B intersection C, so N of B intersection C, but we have to add this, no, because this is already removed. So in order to balance this, we have to again put it back. So this time only once, not twice. Alright, see, initially this is taken, we have to take it out everything, right? Now we have to remove this, but actually we have to remove only this part, but we cannot remove only this, so I have to remove this full thing. So this is also removed along with this, right? So in order to balance this, I have to put it back, but only once. Alright, so we have, okay, so this is already removed. Now in order to put back, we have N of A intersection B intersection C. Let's put the values. So N of C is given to be how much? 11 minus N of A intersection C. So A intersection C is given to be 5. N of B intersection C is given to be 4, plus this is given to be 3. So this turns out to be this 14 minus 9, which is equals to 5. Alright, so I don't have space here. Pause the video and note it down. Okay, now next is we have to find this number 2. So number of students who had taken mathematics only. So this is also similar case. So mathematics means we have to go to set A. So we have to basically find the number of people belonging to this shaded portion, right? So the rule is same. First let's take the entire set A. So from this entire set A, I have to remove these many people. First let's remove these people. And what is this? This is A intersection B, isn't it? So I have to remove A intersection B. Now with that I have to remove this also, right? So I have to remove this also, these people also, okay? But actually in fact we have to remove only this, but we cannot remove this many, so we will remove the entire set this, and we will again put back whatever is removed from here, okay? So this is what, actually this is my A intersection C. So we have n of A intersection C, plus we have to nullify. So to nullify we have to add, and what we need to add is n of A intersection B intersection C. So let's put the value. So n of A is given to be 15, A intersection B is given to be 9, A intersection C is given to be 5, plus this is 3. So we have 15 plus 3 is 18, so this is 14. So my answer for this second part will be 4. Pause the video and note it down. Okay, so number 3 you will try by yourself. It's entirely based on number 1 and 2. It's similar to that. Let me go to question number 4. So question 4 says you have to find the number of people who had taken physics and chemistry but not mathematics. So physics and chemistry means we have to go with B and C, isn't it? So B and C means this. B and C means B intersection C. Now here what happens is we have got this part, if you see, yes. So we have got this part, and what is this part? In this part we have got mathematicians as well, isn't it? So we don't want them to be in this, because we don't want, see, question says who had taken physics and chemistry but not mathematics, right? So that's why I don't want this, so I will remove this from this group, that is B intersection C. So basically what am I going to do is, from B intersection C I need to remove this part, and what is this? This is common to all the three, right? So that's why this is n of A intersection B intersection C. I have to remove this. What is n of B intersection C? B intersection C is given to be 4 minus this is given to be 3. So my answer for this will turn out to be 1. Pause the video and note it down. Okay, so let me take the sixth one. So sixth one is similar to the problem based on newspaper. So here we need to find the number of students who had taken only one of the subjects, or exactly one subject, right? So exactly one subject means either we have to take the mathematicians or physicists or chemists, all right? So we have to find the number of people belonging to this shaded region, which is exactly like your newspaper problem, isn't it? So let's find how to do this. So first and foremost what we did is, first we'll take the group of all these, okay? So first we'll combine all the people, okay? So combine means n of A union B union C. So from this A union B union C I have to remove this part, which is what? Which is A intersection B. So let's remove n of A intersection B. Now again, to remove only this much part, it's not possible, so we will remove this entire thing, which is A intersection C. So this is n of A intersection C. Now again we have to remove this part, yes. So in order to remove this part, I will first subtract n of B intersection C. But here again, initially when I removed this, this was also removed. So later on again I removed this, but this was already removed, right? So in order to nullify this, I have to put n of A intersection B intersection C, and same goes with this as well. So basically n of A intersection B intersection C has to be included how many times? 2 times. So that's why I am writing 2 times n of A intersection B intersection C. Okay, so we have, so this is equal to, so n of A union B union C is given to 23 minus, so this is equals to 9 minus this is equals to 5 minus this is equals to B intersection C is given to 4 plus 2 times this is given to be 3. So this is 6 plus this is 29 minus, so this turns out to be 18, so the difference turns out to be 11. That means the number of students who had taken only one subject or exactly one subject is 11. Pause the video and note it down. Okay, so the next is number of students who had taken at least one of the subjects. So at least means it can be either physics or chemistry or maths. So basically we are putting or. So or means we have to write n of A union B union C, and we have already found this, and this is equals to how much? 23. All right, so this is my answer for 7th one. Pause the video so that we'll see the last one. Okay, so the last part says find the number of students who had taken none of the 3 subjects. So none of the 3 subjects means he has not taken maths, he has not taken chemistry, he has not taken physics. So basically they are talking about find the number of students belonging to this set. So what is this actually? This is my complement. Complement of what? A union B union C. Because whichever part is not shaded, that is what? That is A union B union C, isn't it? Now the complement of this will be the shaded part here. All right, so that's what the question is asking. So basically we need to find complement of A union B union C. Okay, so the formula says this will be equals to n of xi minus n of A union B union C, isn't it? Now n of xi means total number of students in the classroom, and how much is that? It is given to be 25. And what is this equal to? This equals to 23. So what's the difference? Difference is 2. That means there are 2 students who has not taken physics, chemistry and maths. Alright, so pause the video and note it down. So try the sums from your exercise as well. So with this we close for the day. Thank you very much.